Well, we have another question here. Question 8. The question says that f of x equal to 2x cubed minus 5x squared plus 4x. Okay. And then question 8.1 says calculate the coordinates of the turning points of the graph of f. Well, I'm gonna write the question over here. 8. Okay. Question 8. We have like f of x equal to 2x cubed minus 5x squared plus 4x. Okay. So now, this being a cubic function, it means that okay, a cubic function means that it has a maximum of 2 turning points. So we look at the leading coefficients here, 2, which is positive. It means that its graph, the graph of the function, is like increasing, decreasing, increasing again. The function must look like this. Okay, just giving insight of what the question is all about, the function f of x is all about. Now, we're doing like question 8.1, looking for the coordinates of the turning point. I call them xtp, okay? But let's just call them x. Let's just keep it xtp, the coordinate of the turning point. Now, the turning points are basically this point here and the points here. So there is a maximum of 2 turning points in a cubic function. Now, we're looking for those points. The turning point occurs when the derivative of the function is equal to 0. It is why the tangent line, okay, is horizontal. So tangent line is horizontal if the gradient is 0. Remember that the gradient of the function is the derivative of the function as well. So when the gradient is 0, meaning the derivative is 0. This is why we're gonna say this implies that f prime of x equal to 0. Okay, so let's find it now. F prime of x will be what? According to the derivative function formula, this will be on the right here 3 times 2x to the power of 3 minus 1, okay, and then minus 2 times 5 times x to the power of 2, and then plus just 4. Okay, the derivative formula says that if you have like a x to the power of n derivative, this is like n times a times x to the power of n minus 1. This is the formula. Okay, now when we have like terms like this, we can differentiate each term when we differentiate the whole function. Now over here, for instance, I do 3 first according to the formula here, n times a times x to the power of n minus 1. So n first, the exponent is 3. So I write 3 there, times a, which is 2, the coefficient of x squared. Okay, the coefficient of x cubed here in this case, and then to the power of 3 minus 1. Same with this. Here I meant to write 2 minus 1. So let's simplify. The derivative would be equal to 6x squared minus 10x plus 4. That's the derivative. Now we're going to set this derivative equal to 0 because that was the condition. Now we notice that each term here of the function is a multiple of 2, so we can just divide by 2. Divide by 2 each term. This will be just I prefer to write 0 on the right hand side, so it's going to be like 3x squared minus 5x plus 2 equal to 0. Now we have a trinomial. We can solve this by factorization, for instance. This is what we do. Because we have a coefficient here different than 1. Okay, I want to take 3 times the last term. Okay, 3 times 2 equal to what? Equals 6. Now positive 6. Okay, now what are the factors of 6? They are like preferably in ascending order. They are like 1 and 6. 2 and 3. Now I want to say to myself, which couple of of the factors of 6 will make a sum equal to the coefficient of x? -5. Now let's see, how can I get -5 here? We can notice that with 1 and 6, yes, we can get -5 if we do if it's like +1 minus 6. But +1 times -6 makes +6? No, so not this. With 2 and 3, yes, we can still get -5 if we do a -2 and -3. But will -2 times -3 +6? Yes. So I can extend this trinomial into 4 terms. Instead of me writing like 3x squared, I am going to write 3. I'm going to write like 3x squared. Instead of writing like -5x, I am going to write -2x, -3x, knowing that they all make -5x, and then plus 2 equal to 0. Now we can select get a common factor here and here. The common factor is just x, so take x as the common factor, and then in the bracket it will be like 3x minus 2, and then also the last two terms. I factorize this by grouping the last two terms. We can take -1 as a common factor. Okay. -1 is a common factor, and then what should be in the bracket? Okay, 3x plus 2, right? Careful here, -2, because we did take a negative factor. So if you times back, you get -3x. -1 times -2 makes +2 here. Okay, and then this is equal to 0. Now you notice that we have this and that common. Whenever we have this common, we can just factorize this like 3x minus 2, and then x minus 1 equal to 0. Now, if this is equal to 0, okay, it means that either 3x minus 2 equal to 0, or x minus 1 equal to 0. So we can move the -2 over. That makes like 3x equals to 2, or x equals to 1. Now, we can solve this. If I divide both sides by 3, and then this will be x equal to 2 over 3, or yeah, we have like x is 1. So those are the values of the turning point. Okay, the x turning point. We have that and 1. Yeah. And no, not yet. You know, turning points, the question says calculate coordinates. It means we need to find the x. A point has 2 coordinates, x and y coordinates. Now that we find the x coordinate, we're going to use this point, these values, to substitute into the main function to get the y coordinate. So now, just do it somewhere. Let's just move it, do it over here. So I'm going to sub in, okay? I'm gonna write here 4x equal to 2 over 3, okay? Y was what is the function? Okay, the function was given by 2x cubed minus 5x squared plus 4x. Now we're going to substitute the value of x wherever we have like, okay, we can sub in the values of x. So if x is 2/3, so it's gonna be like 2 over 3 there, and 2 over 3 there, and 2 over 3 there. Okay, we can use a calculator for that. Use a calculator. So this will be like 2. Okay, open brackets, 2 over 3. Okay, to the power of 3, and then minus 5, excuse me, open brackets, 2 over 3 to the power of 2, and then plus 4, 2 over 3 there, close bracket. Now, if we hit equal, and then we get 28 over 27. So when x is equal to 2 over 3, y will be equal to 28 over 27. Now, for x equal 1, this will be, we're going to sub in the value of x there. X is 1 there. So in the calculator here, we can just sub in the value of x. So we delete this one, delete the fraction. X is 1 now. And then there also 1. And then when we hit equal, and then when for x is equal to 1, y is also equal to 1. So y will be equal to 1. So the turning point, okay, I shouldn't like enclose this like that. I just do it. Okay, so therefore, the turning points are the points 2/3 28 over 27, okay, and the point 1, 1. Okay. The other question, the following question is question 8.2. Move the board like this and then see what the question says. Okay, the question here, question 8.2 says prove that the equation 2x cubed minus 5x squared plus 4x equal to 0 has only one real root. All right, now let's see. I'm gonna move my board over here. Question 7.2, actually 8.2. 8.2. So we need to prove that it has only one real root. Okay, how can we do that? First of all, we're going to solve this by factorization. Okay, the function is given by we're gonna set it equal to 0. This is why we determine that the function has a root. So it is like 2x cubed, okay, minus 5x squared plus 4x equal to 0. We set it equal to 0. This is how we determine that the function has a root. Now, I'm going to, we notice that each term here has an x, so we can take x as a common factor. So we can take x as a common factor, and then this will be like 2x squared minus 5x plus 4 equal to 0. So this means that x is equal to 0. That's one root, or 2x squared minus 5x plus 4 equal to 0. This can generate other roots if they are. Remember, we said it has a cubic function has a maximum of 3 roots. It can be 3, 2, 1, or no root at all. Can it? No. The cubic function may have one root, yes. One root. So the maximum number of roots are 3. It can be 3, it can be 2, it can be 1. Now, in this case, we need to prove it has only one root. Now, over here, let's see if we can factorize this. Okay, if I do 2 times 4, how much is that? It's 8. I'm gonna write it over here, 8. Then, if I want to list all the factors of 8, okay, they are like 1 and 8, 2 and 4. Is there any couple here can make a sum equal to -5? any combination. So this is not possible. We cannot get -5 on any of these. So this is type of prime equations. So we have to use the quadratic formula, and then the quadratic formula is given by x equal to the quadratic formula is x equal to minus b plus minus square root of b squared minus 4ac, okay, over 2a. Okay, this is when the quadratic equation itself is x squared plus, because the quadratic equation itself is like this. Now, let's see if we can find the roots here. I'm gonna say x is equal to minus b, okay, plus minus square root of b squared minus 4ac, okay, all over 2a. Now let's sub in b. In this case is the coefficient of x. Okay, b is the coefficient of x, so -5. So -5 there, plus minus square root of -5 b squared minus 4a. A is the coefficient of x squared, so 2. Sub 2 over here, and then c is the constant term. The constant term here is 4. I'm going to sub 4 there over 2a. A is 2. Now this will be equal to x equal to -5 makes positive 5 plus minus square root of 25 minus 4 times 2 is 8. 8 times 4 is 32. 32 over 4 here. So this implies that x is equal to 5 plus minus square root of 25 minus 32 is 7, or -7 actually. -7 over 4. Now, can we work out, okay, the root of -7 here? This is non-real. Therefore, I'm going to say here this is non-real. Non-real. So therefore, the only real root here is 0. The one we find over here. Okay. The next question will be question number 8.3. Number 8.3, the question says that sketch the graph of f clearly indicates the intercept with the axis and the point and the turning point. Now, I'm gonna do it over here. Let me just show the graph. Let's try it over here. This is the vertical axis, and then I want to do the horizontal axis also. Okay, the y-axis, and that's the horizontal axis. Now, in the previous question, we did prove that this graph has only one real root. So the real root is 0. So the function passes through 0, and that's the only one real root. So I'm gonna write here 0. And then it's clear that it is also clear that it is 0 because the function, let me write it here. This is question 8.3. Oops. 8.3. The function is given by f of x is 2x cubed minus 5x squared plus 4x. Okay, so now because the constant term is d is 0, of course the points the constant term is 0. It means this means the y-intercept. So the y-intercept is just 0. So the function and the turning point we had 28 over 22, 3, and 28 over 27. Okay, and then that's 1. So 2 over 3 is closer. It's 0.67. Okay, if you're sure, you can check it here. 2 over 3 equal, if you press SD, you get 0.66. This means the 6 is recurring, 6666. So this is rounded to 0.67. So now 2 over 3 is closer to 1. Let's say 1 is here. Let's say 1 is, okay, let's say 1. Not like this. Let's say 1 is here, and then 2 over 3 must be somewhere there. So if 1 is here, 2 over 3 somewhere there, and then 28 over 27 is like a little bit more than 1. Okay, and the other one is 1 1. So if 1 is there, let's say 1 is also over here. 28 over 27 somewhere, let's say 20 somewhere there, and then 1 will be somewhere there. Now my graph will be like something like this. The turning point here, another turning point there. Okay. And then the graph will be something like, it goes down like that. Over here it comes and then turns and then goes up again. Yes. Here is the point, the turning point, 2 over 3, and then 28 over 27. And that's also the other point, 1 1. Okay. And the other function is the other question is question 8.4. The question says that for which values of x will the graph of f be concave up? Right. Let's see. So I move my board like over here. Yeah, right here. 8.4. I'm looking for which value or values of x for which f of x concave up. Okay. So now concave up is when the second derivative, okay, of the function is greater than 0. So in this situation, we did work the first derivative of the function f prime of x. This was equal to 6x squared minus 10x plus 4. Okay, now we're going to work out the second derivative. This will be equal to applying the same formulas for the derivative. So 2 times 6, 2 times 6 times x to the power of 2 minus 1 minus 10. Okay, remember that when you don't see any exponents here, understand it's 1. So it's just like 1 times 10 times x to the power of 1 minus 1 plus 4. The derivative is 0. The derivative of all the constants is just 0. And then okay, we can do it here. And then we have like f, second derivative will be equal to 12x minus 10, 10, because 1 minus 1 is 0 and x to the power of 0 is just 1. So this makes 12x minus 10. So now this, we're going to set it greater than 0. This means that 12x is greater than 10. So if I divide by 6, both sides by 6, n by 6. And then this will be y by 6. I can just divide by 12. Ish. So you can just divide by 12. And divide by 12. By 12 here, and then by 12 here, because I need to do the values of x. And then by 12, like x is greater than 5/6. So this is these are the values of x for which the function f of x concave up. Thank you.